This lesson, we are introducing the idea of an indefinite integral. And an indefinite integral, we use this little symbol right here, represents an integral. It means that we're about to do the antiderivative of whatever this function is. And it's known as an indefinite integral. There are definite integrals and there are indefinite integrals. So we're focusing on that. So here's kind of the rule, just like when you do a derivative, that if we were to do the derivative of x cubed, the power would come in front. So we would multiply the power and subtract it. If you're going to undo that, exactly the opposite's happening. So if this is what you have, you're going to add a power. We're doing exactly the opposite of doing the derivative. So we're going to add a power and then divide by whatever that power is. Right. So that's kind of where we're at of some of the derivatives. We're going to get to more challenging ones, but right now we're just kind of focused on the power rule. Okay. So and then if you have any kind of a number in front, a lot of times it's easier maybe by taking that value out. Kind of depends on how it connects to it, but it's always a thing where you can take it out and then just focus on the function on the inside. Sometimes it's good, sometimes it's worth it, sometimes it may not be necessary. And if you have individual pieces added together, you can just individually do the antiderivatives of each of them. All right, so like on something like this, I can do the antiderivative of this, antiderivative of this. I can do them totally independent of each other. So if this is what I have, I'm going to go through this power. And you may or may not need this, but here's kind of the underlying math that's happening. So this represents, and I'm about to do the antiderivative of this. So if I'm going to follow this idea of how this would work would be to do the antiderivative, I would take this power, I would add a power to it. So let me kind of work through the math here a little bit better. So I would take the original power of cubed, I would add one to it and then divide by that. Right, that's the idea. So we're undoing the derivative because the derivative would be multiplying and subtracting. So we're going to be adding and dividing. So what I'm really looking at is 4x to the fourth divided by 4, which then simplifies to just an x to the fourth. And so that's our antiderivative plus some sort of a constant that might be there. Because if you were to do the derivative of this, we would bring the 4 down, we would subtract a power, but there might be some sort of a constant here that would end up going away. And we don't know if there was one, so we're going to assume that there was, and we'll put a plus c at the end of every single one of these. All right, so I can do that on every single one. We'll go a little bit quicker. On this one, what I do want to write this is 5x to the 1/2 power. All right, so if I'm looking to do this, I'm going to take this original, I'm going to add a power and divide by that power. On this one, I'm going to make a constant become an x as a power of 1, and I'm going to divide by 1. And then minus, I'm going to add a power, so 1/2 plus 1 is going to be 3/2. And I'm going to divide by that 3/2. All right, so my antiderivative here, I'm going to simplify this into 1/2 x to the 6th plus a 2x minus this math right here is 5 divided by 3/2, or 5 times the reciprocal. So we're looking at 10/3. So minus a 10/3 x to the 3/2. So there's the antiderivative, most of the antiderivative, plus c. Easy to forget. All right, and then we'll do one last. Now this one looks like we should have a lot more going on to it, but what we can end up doing is simplifying it. And so before I do the antiderivative, I can take this and break it up, take that x squared and break it up into each of them. So I'd have a 4x to the 19th over x squared minus a 5x to the -8 divided by x squared. And I can look at it like that. All right, so before I do the antiderivative, let's simplify this. And so this, I can take 2 of the x's from here, cancel it with 2 of the x's up here. So we're looking at 4x to the 17th. And then the property is that we subtracted that power. We took 19 minus 2. So we're going to take negative 8 minus 2. And that's going to get us a negative 10 power. All right, now we're ready to do the derivative of that, or the antiderivative of that. So we do the antiderivative of that. We're going to add our power and divide by that power. We're going to add a power, divide by that power. So I'm going to have a minus 5x. Now be careful with negatives. We're going to add a power to that. So it's going to make it a negative 9. And we're going to divide by that negative 9. All right, so let's simplify this out. I can take a 2 out of each of those. So that'll be a 2/9. So I have a 2/9 x to the 18th. And then plus, because those signs would cancel, a 5/9. And let's go ahead and make that power positive. So we'll bring it down to the 9 that's already down there. And then plus c. Can't forget to add that piece into it. And that is our antiderivative. And if you're ever questioning it, you can always go ahead and redo your derivative. So if I were to redo this, the 18 would come down. We would be able to simplify it. It would become a 4x to the 17th. I would bring this power up just like this, and then do the derivative, and it should simplify all back. All right, so there's definitely a nice way to check to make sure everything's kind of working and feeling like it's supposed to.